for that. So without further ado, I'd like all of you to give a warm welcome to Joe Ludwig to the stage. All right.
Hi, everybody. I'm Joe Ludwig. I work on the VR team at Valve. And we're doing a bunch of different stuff in VR, and I wanted to go through what some of those are and what they mean, why we're doing them. And we're doing all this stuff under the banner of Steam VR. That includes the Vive headset that we're building with HTC, the OpenVR SDK, the Lighthouse tracking system, the Steam VR controllers, access to Steam itself from within VR, and various improvements we're working on to the Steam store to make it easier to find VR titles. And today I wanted to talk about a couple of those in detail and describe why we're doing what we're doing. I'll start with a short introduction to the HTC Vive, then talk a little bit about where Lighthouse came from and where we're going with it, and then take a deeper dive into OpenVR. And I'm not really going to get into the store, the Steam integration in VR, or the controllers, but there is plenty of time at the end for questions, so if you have any questions about those, ask them at that point. Let's start with a quick recap on the HTC Vive. This is a headset that HTC is building that has one screen per eye. They're 1080 by 1200 pixels each, and those screens update at 90 frames a second. It features the Steam VR tracked controllers, and the system uses Lighthouse to track the Vive. So that means that the Vive and the controllers can be tracked in a tracking area that's about 15 feet across. Applications can access all this hardware through OpenVR. So I wanted to get into a little bit about where Lighthouse came from. When we first started looking at VR 3.5 years ago, we went out and bought the best, the best displays we could get our hands on. And this one is the SX111 from Enviz. It costs about $20K, but it doesn't come with any tracking. For a little bit more money, and by a little bit I mean like $1,000, you could add an IMU and get rotation-only tracking. In terms of resolution and field of view, it's about the same as the consumer-level displays that people are talking about now, although it was significantly heavier. And that was a common theme that we saw with the headsets that we could buy off the shelf 3 years ago. A bunch of people were doing okay on displays, but nobody had a tracking solution. So we had to build one of our own. Our first attempt was the fiducial marker system that you may have seen in the room demo, or at least seen pictures of in the room demo. And from that we learned the value of room scale 360-degree tracking. Never losing tracking and being able to move around freely are key components of presence, and presence unlocked experiences that almost no one had seen before this demo. As powerful as this system was, though, it had some limitations. It turns out that most people don't want their rooms to look like this. And with markers all over the wall, that just wasn't going to work. So there were some issues there. The performance of this system also scaled very poorly to controllers, because to support controllers, we would have had to put cameras on the controllers, which would mean video bandwidth all the way back to the PC and various other processing problems. Our next attempt solved some of the problems of the first system. Our dot tracking system can be deployed without removing all the furniture in your room. And it also handles controllers pretty well. Unfortunately, it also places significant restrictions on the physical shape of tracked objects. If the angular Battlestar Galactica classic industrial design was not what you were going for, then this is not the tracking system for you. Because of the outside-in camera, this also had significant limitations on field of view and range. So we lost room scale while we were fixing some of these other things. Lighthouse took the best attributes of each of our previous tracking systems and put them all in one system. Lighthouse supports 360-degree room scale tracking for headsets and controllers. Also, the base stations themselves only transmit light and don't get any data back from the receivers. That means that they support any number of tracked objects that can fit in the tracking area. It also means that base stations from one company can work with receivers from another company, which we're hoping will be a very common situation going forward. Shipping the Vive will help us to get that base station light pattern locked down. And once that happens, we're going to share this technology as widely as possible. And there are a few major reasons for that. The first is that standardizing VR tracking on one system is great for consumers. It means they only have to learn one system, and it will also drive prices down and drive performance up as quickly as possible. Users also want controllers and other track devices to be tracked in the same coordinate system as their HMD. So using Lighthouse for all of those devices will make that happen with no additional complexity. The other thing is what I was describing about those early HMDs that we bought. Many VR hardware companies are focused on things other than tracking. And they have interesting devices, but they don't have a tracking solution. So using Lighthouse will let those companies bring their devices to market, which means more innovative new products for VR consumers. Eventually, we hope Lighthouse will be a bit like Wi-Fi. There are all sorts of applications that could take advantage of a very precise indoor location system if that system were widely available. And all of the consumer benefits I just mentioned help with that. Lighthouse also has another benefit for use in public, though. Because the base stations themselves don't know anything about the objects that are being tracked by them, there's no privacy implication to using a public Lighthouse system that someone else owns. So sharing the Lighthouse technology is something that we're doing to enable innovation in VR. And enabling innovation is also a big part of what we're working on with OpenVR. As a result, the most important characteristic of OpenVR is that it has no gatekeepers. Nobody can tell you what games you can and can't make with OpenVR. The SDK is distributed on a license with no content restrictions whatsoever. There's no certification process for OpenVR applications. And while many OpenVR applications will be distributed on Steam, and we want Steam to be an attractive place for VR games and applications, there's absolutely no requirement that these applications be distributed on Steam. Anybody who wants to can build anything they want and distribute their application to whoever they want. The PC ecosystem is another example of a system with no gatekeepers. All of these things on this list happen first on the PC because nobody could make Netscape jump through hoops on the PC. And because the web itself is just as open, there's been an explosion in innovation in software and PC hardware over the last 20 years. This has been fantastic for consumers and developers alike. And we see VR as an extension of the PC ecosystem, and we want to do everything we can to prevent gatekeepers from springing up in this new industry. We also want to minimize the barriers to launching new VR hardware. A major challenge for new hardware vendors is building software developer interest in that new device. OpenVR attempts to address this directly by allowing existing titles to run on new hardware without any changes. That includes both new hardware from existing vendors and entirely new hardware vendors. Once the Lighthouse system has been shared more widely, we also expect new Lighthouse devices to work in OpenVR without the companies making those devices actually needing to write any code, at least on the driver's side. So what hardware does OpenVR support right now? It supports the HTC Vive Developer Edition, and it will support the Consumer Vive release also. The API also supports the Oculus Rift DK1 and DK2. And as they mentioned, Razer and Sensix made an announcement this morning that they're working on an OSVR driver for OpenVR that will allow OpenVR to support those devices. The driver model in OpenVR allows OpenVR applications to be future-proof without requiring any binary changes to the games. Not requiring the game to change or recompile to support new hardware is very important. Often a game team will move on to another project after a game ships. And that means that many games will never receive another update after the first month or two. That's why there are dozens of games on Steam with VR support that only support DK1 and will never support anything newer unless they ship an update. Games that use OpenVR won't have that problem. When an existing vendor ships a new headset, or when an entirely new vendor adds an OpenVR driver, all OpenVR games will get support for that hardware automatically. And this story has happened before. Many of you might remember that 3DFX used to be the dominant PC 3D graphics card vendor. Well, back in the late 90s, they had an API called Glide that game developers could use to target their hardware. And during the few years when Glide dominated, lots and lots of 3D games used Glide to talk to 3DFX hardware. Unfortunately, some of them only targeted Glide, and now the only way to play those games is to find on eBay a late 90s 3DFX video card or through a Glide emulator. And we think that there are lessons to learn here about how quickly things can evolve. The API and runtime currently support Windows, OS X, and Linux. The Unity and Unreal plugins are supported on all three of those platforms also. And this is one place where we hope that OpenVR will diverge from the DirectX versus Glide example. Making the single API available on non-Windows platforms means that developers will have more customers to sell to and that consumers will have more choices on the platform that they use. And the source of all this future-proofing is the architecture of OpenVR. The game ships with a tiny shared library whose job it is to find and load the installed OpenVR runtime. And the runtime itself is available for free on Steam, which allows us to keep things up to date and add new or updated hardware drivers as needed. And while we're talking about the various parts of OpenVR, I should probably mention what it actually does. Let's start with the chaperone system. You see that blue rectangle on the ground in this image? When the user sets up the system, one of the first things they do is calibrate their safe area. And that's what this blue rectangle represents. This is the area that they can move around freely without worrying about running into things in the real world. This area is provided to the game or application through the OpenVR API, so that the safe area can be represented in a way that's native to the design language of that experience, which lets the user keep general awareness of where they are without being pulled out of the experience. The other thing the user calibrates are their hard bounds. These are the surfaces that the user might be near enough to collide with. These are generally not drawn, but if the user gets too close to something solid, either with their head or with their controllers in their hands, then the compositor will step in and will draw the hard bounds over the game. This lets the user know that they should back off so they can avoid running into walls or other obstacles. And this also allows the user to feel somewhat more safe because they're blinded by the headset in terms of what's in the real world. So this gives them a way to sort of keep themselves safe while they're playing in VR. The compositor is a part of OpenVR that owns the actual output to the display. It performs the distortion necessary to make things look right once the light goes through the lenses. It also draws the user's hard bounds over the application when the user is in danger of a collision. And the third thing it does is to provide a safety net in case the application crashes or freezes. If an app stops providing 3D frames to the compositor, it will quickly fade back to a simple but tracked grid. This avoids the disorientation that happens when a 3D scene is stuck to your face and not tracking. OpenVR also provides the application with predicted poses for each tracked object. The poses themselves are generated by the native tracking system of the hardware and are then mapped into the coordinate system that the user configured when they configured their chaperone calibration. And while the position and orientation is provided by the tracking system, the state of all the buttons is provided by the input system. So this system is also responsible for the haptic requests back out to the controllers. The system supports wired and wireless controllers and can easily be mapped onto a wide variety of different controller styles. So before moving on to questions, and we do have plenty of time for questions, so if you have some, get those ready. I wanted to recap what we've already talked about. The first is there are no restrictions on what applications you can build with OpenVR. You can distribute your application through Steam, through another digital download service, directly to your customers, or don't distribute it at all and keep it internal to your organization. You can sell it, give it away for free, or come up with some new business model. And if you're a hardware vendor, you can build a new device and make a driver for it without asking for permission. Sell or give away your new widget to whoever you want through whatever channels you want. And once the Vive is shipped and the tracking system specs are stabilized, you can use Lighthouse to track your device. So that's what I have. Who's got questions? Are there mics here somewhere?
Check, check. With frame rate absolutely paramount for obviously avoiding motion sickness and when you're walking around possibly losing tracking and losing balance or something like that. Have there been considerations to a kind of drastic revamping of the way rendering systems work, underlying that maybe prioritizes keeping 90 frames per second, or whatever the baseline FPS is, and excluding things like draw calls and just trashing stuff to always maintain frame rate? Is that something that...
So we've had a number of long and involved conversations with Microsoft, NVIDIA, and AMD about those topics. I don't have anything to announce today, but lots of people are thinking about that problem. So I imagine going forward there will be a lot of sort of progress on it.
Your API currently supports edge tracking and hand tracking. What about more esoteric devices like body suits and so on?
The API will support tracking any number of objects. Right now, it's built around rigid bodies. So for a body tracking system, like if you had cuffs around your ankle and a waist tracker and I guess hands, at that point would probably get you enough. Having that number of inputs would not be a problem. Exactly how to synthesize that into a skeleton in a game is not something that we've sort of worked out all the details to, but
That is connected to the hardware. I mean, if you have a suit that has IMU, like perception neuron or control VR, pyro VR, they give you essentially joint orientations on absolute space.
joint orientations probably won't get you all the way there because there would be ambiguities. But that's once we get Lighthouse shipped, we'll be working with everybody who wants to track things to try to get it as widespread as possible.
Hi, less technical question. When and where can we see a demo of the Vive and OpenVR?
I don't
A fan favorite question.
I don't have a great answer for you, unfortunately. We're doing a bunch of demos at our office in Seattle, so if you happen to be in Seattle, for VR and game developers, we're happy to do demos. And throughout the rest of the year, as we get closer to shipping, both Valve and HTC will have lots of demo opportunities. We want people to actually see it so that they can develop for it and eventually buy it.
So for SteamOS, I guess what are you guys doing to make it so that developers building like Windows games can really easily support SteamOS when it comes out as like a console alternative? Is the porting going to be really easy, or is it like you're just hoping? Because yeah, I guess.
So the vast majority of game developers use either Unity or Unreal.
Right.
And Unity and Unreal both support Linux and SteamOS natively. So I would suggest using one of those as your best ticket.
Okay, thanks.
Develop content.
Just speak loud. We have a startup that's developing content, and mostly for experiences we're not doing games yet. It seems that we're gonna have a challenge getting, HTC Vive prototype, which is okay. But I'm curious if Valve has been giving any attention to experiences. I know that Oculus has, as opposed to just games, maybe having something on the Steam platform or a different platform.
So we've had, so the question was, are we focusing on games or are we paying attention to non-game experiences? And we've had many people fill out that form to request an HTC Vive dev kit, and many of them are not game developers. So I don't, while there will be plenty of games, and I would expect games to be fairly well represented in the first round of software, we're talking to everybody about all sorts of different applications.
So you guys are obviously pretty interested in the Steam box and SteamOS. Is there any specific setup in terms of how you would start to deal with hardware vendors not supporting your platform of choice? So say for Linux and for OS X, now with the recent news from Oculus.
So I said that the runtime would support those three platforms. Unfortunately, we don't have control over all the device drivers, so if Oculus doesn't support platform, then it's difficult for us to support that platform on their hardware, to support those things as widely as possible. And by taking as much of the SDK load off of the hardware developers as we can, we're hoping that that will make it easier, because it's a relatively small amount of code between OpenVR and the hardware on the bottom end of the stack. It should be relatively simple to support that hardware.
Hi. Will OpenVR support time warp for rendering to like a DK2's rolling shutter display? Or,
So we've done some experiments with that. We're still trying to figure out, I mean, we saw the announcement on Friday at the same time as everyone else. So we're trying to figure out exactly what that means and how we'll roll that into sort of newer versions of the interface.
Hi there. What are the minimum space requirements for the Lighthouse system?
So the Lighthouse is probably maybe 1.5 feet is about as close as you want to get to a base station. And your field of view, I mean, it's 120 degrees on the base station, so it's pretty wide, but it's more about field of view than anything else. And as far as how small the experiences will support, that's kind of up to the people building those experiences. The 15-foot range that we talk about is the maximum range. It's actually the maximum distance from the base station to the tracked object. So if you take a 120-degree field of view and you put one on either side, you end up with sort of an eye-shaped zone where your tracking will be good. And within that, you can pretty easily draw a square that's 15 feet across the diagonal. But smaller than that will work fine.
So 1.5 feet, you said, from the about.
I don't actually know what the current hardware is doing. I know that a couple of generations ago, the base stations had within 3 feet, they had some tracking problems. But I'm not sure exactly where we're at right now. The tracking volume doesn't necessarily have to be right next to the base station, though. So if you have an area that's 2 or 3 feet across, you could still have your base station 10 feet from you, and you'd be within 15 feet. So you'd be within the volume.
I think a lot of the concern is the current generation of headsets is very much a sitting in front of your computer experience in a pretty small space, I think. And whereas the Lighthouse system kind of implies that you're going to need a much wider open space. And so, if people are still going to be able to use this, given that existing, right in front of their computer that they're using right now for these VR experiences.
It's all down to what experiences you're into. The seated is an easier problem than room scale. So if we support room scale, we definitely support seated.
Hey, Joe. I got a lot of questions answered about the Lighthouse by Alan Yates yesterday at the Maker Faire, and I want to thank you guys for bringing them to Maker Faire and being one of the companies that support that. So I don't want to ask about that. I want to ask you a personal question. When do we get to play Hard Takeoff, your card game? I'm excited about that, and I don't see you following up on it on your blog anymore, and I've been following your blog.
It's kind of, I've had a bunch of I'm working on just a board game, card game, and it's had a bunch of terrible builds, and I keep revising it. And
great concept.
You might be the only one.
Well,
I'm working on it, but
That's
it might be a few more years.
So seriously, I mean, you may not do any more updates or follow-ups on it.
I have another build that I haven't actually play tested yet, so
There are
I'm
people
working toward it.
interested, and we wanna
I've been
play.
busy working on VR.
The man's been busy.
So are there any plans for OpenVR to support Android?
There are no specific plans, but there's nothing that would stand in the way of that. We'd be happy for it to support Android. It's just not something anybody's working on quite yet.
But can anybody else do that besides you guys?
If you want to work on porting it to Android, then shoot me an email and we can work it out.
And a related question is, what is the relationship between OpenVR and OSVR?
So OSVR, the folks at Razer have made a driver that operates as an OpenVR driver. And so any OSVR HMD or other hardware would then work through the OpenVR API. OpenVR is a bit higher level, like it's closer to the application, a little further from the hardware. So that's sort of the relationship as we see it.
Thanks.
Hey Joe, quick general question here. So I know like recently there's been like the mobile VR jam, we've got like Unreal Engine with their grant and stuff like that. I'm just wondering if Valve has any plans or what your guys' perspective is on supporting content developers. Are you planning on maybe doing a jam for the Vive? I know there was the thing in Austin, but since the hardware is not really available, that doesn't count in my mind anyway. So I'm just wondering if you guys have plans to do something similar like that, or how you plan to inspire developers to start pumping out content for the platform.
So We did have the VR Jam in Austin last week, or week before last. And I think we had 70 teams come out for that. The biggest thing we're going to do is start shipping the developer edition, and that will happen very, very soon.
So no plans, no announcements to make it this time?
No, I have no announcements to make it this time.
Hi, my question was related to the boundary system that you have. I'm curious if you have any guidelines or better use cases for how to keep the gameplay going without totally disrupting it when you have like a red screen thrown up in front of you.
So you want to avoid the point at which the user is like in danger. You want to give them, you want them to have ambient awareness of the space that they're in. So a fine example of that was one of the demos from GDC, the Blue, took place on the deck of a sunken ship. Separated you from the back of the ship, you're fine. And you can walk around freely in that space and you don't have to worry about it. You're never going to see the grid pop up and say you're too close to the wall.
Would it be easy for the developers to have their environments scale to the different spaces?
We don't know exactly how that's going to turn out and the earlier question sort of plays into this about the size of the experience. We don't know yet what the answer is to how do you tell a customer how much space they need, and how do you tell a level designer how much space they need. So if you as I'm not actually sure, but if you're an application developer, we'd love to talk about that and sort of get your feedback about how that would work.
Thanks.
I'm gonna sneak in a question here, Joe. So getting hardware has definitely been, it seems like what's on everyone's mind, right? And the method that Valve has had so far is like, hey, put some information in a little form, but VR is really one of those things that to understand what a person is doing, really trying it is the best way. So how do we get that little indie developer, or maybe that, that application that's gets good impressions but doesn't look as great on paper when you describe it, how do we get Valve employees to see what we're working on and really get them excited to give us some hardware? How would you advise folks that are in that position?
So a lot of people will bring demos with them when they come up to get a demo from us. So that's one way to do it. The biggest thing though is that we're shipping this year. So there aren't that many months left in this year. Go buy some retail hardware and you have a dev kit. And the retail hardware is better than the dev kit in every way. It's just more productized, it's more reliable and all that. HTC made the hardware instead of Valve. So worst case, do that.
Okay, so OpenVR as it exists right now on GitHub is a header and a few static libs. Is that the
They're
plan
dynamic
for going
libs,
forward?
but
Well, okay.
Close.
Fair enough. Is that the plan going forward, or is that just a stopgap to get into developers' hands faster?
So what's up there now is the SDK. We're working on how to open it up more and exactly what to share. And probably our next step is a hardware driver side. But we're working on that. We don't want it to be this tightly controlled thing that only Valve gets to see the source code for. So that's a thing that we're working on actively.
So if I'm trying to develop some sort of new prototype of a controller or device that I want to have Lighthouse tracking on, like my ideal right now is a tablet case that you can put Lighthouse tracking on. Is Valve going to have any sort of dev kit support for I want to add Lighthouse controllers or Lighthouse tracking to XYZ device, short of just strapping one of the existing controllers onto my Xbox controller or my tablet?
So that would be pretty entertaining to see. You'd have this big controller stuck on another controller. So we've basically done that. I don't think I have any shots of it, but if you look at like this image, these happen to be the wireless controllers where this is less the case, but the wired controllers that we showed at GDC, they're two physical devices that are only connected by screws. So they're basically what you're describing. And we're expecting that when we get the light pattern stabilized and we feel like we can ship a hardware dev kit, that's basically what it will be. Is here's a tracking puck, attach it to whatever you want to attach it to, and then you'll have tracking.
Okay, thanks.
So if our team wanted to develop something for the HTC Vive, but we're not perhaps lucky enough to get one of the development kits, could we, using OpenVR, develop for, say, other input devices and other HMDs, and then port it fairly easily? Like, is anyone doing that?
I don't know of anybody doing that specifically. It would be difficult to get the user interaction right without the controllers, without the same controllers, I mean. But at least for the output side, we have a driver that doesn't support any hardware that we're looking at beefing up to make it easier to, you might, even if I send you a dev kit, you probably are not alone on your team, so having other people able to render things also would be important. So we're sort of starting to think about that a bit. Mostly we just want to get hardware out there to as many people as possible.
Great.
Hi, Joe. So you mentioned some enhancements to the Steam store that you might be making around VR to make VR apps more discoverable. And I'm also interested in what other kind of software or UX tools that might be coming down the pipeline from, for instance, like in-app purchasing or social features, those sorts of things that might be making their way onto being optimized for VR. And if you could characterize a bit more about that, that'd be great.
A lot of that is not really settled yet, which is why I didn't go into it in any real detail. We do want to make it as easy as possible for people to find experiences. We want it to be easy to find, an experience that will fit your comfort level. Like some people can handle running around and first-person shooter sort of input modes, and many people can't. So the same sorts of features that, all those features would be important for that. As far as social features go, we don't really have any specific plans there.
With the Lighthouse tracking system, how does it handle mirrors or, say, a stainless refrigerator in the room?
Well, I keep telling people we should ship a can of spray paint with the dev kit. You can just solve that problem. But there are two answers to that question. One is, mirrors do reflect the light. So depending on where the mirror is and where the base station is and where the device is, it may be a bad thing. They're also, because the tracking system is pretty accurate, mirrors will often make it look like a device is here when it's really over there. And that kind of difference, we're working on filtering to help with that. And if we don't have any more Lighthouse questions, I have a video. Let's see if it plays. There we go. So this is a Lighthouse base station in action. And the way this works is 60 times a second, it flashes a blinker, just global strobe of light, followed by one of the laser sweeps, and then it flashes again and follows the other laser sweep. And so between those two, between the flash and the sweep hitting a given sensor, we can time that. Computers are pretty good at timing things. And with that timing information, we then know the angle of that sensor relative to that axis on the base station. So you do that in 2 axes, and you do that for each sensor on a device where they're all rigidly attached to each other, and you figure out where you are. The old flash and sweep. What? Give a mic.
Give a video of it in real time at the 60 frames a second, and also are there any
like
issues?
It was blinking.
All right, any issues with triggering epilepsy?
I'm not aware of any specific issues with epilepsy. I don't know what the requirements are there.
I haven't a clue. All I know is strobes and flashing lights, there's always warnings.
So this should be flashing fast enough. So actually, here's the real answer. The developer edition, these are infrared, so you can't see them.
Cool. Thanks.
No more questions?
Yeah, and I think that's perfect. We reached the end of our time.
All right.
So.
Thank you.
All right, in about 5 minutes, we're going to move to our next presenter. The future of VR is user created, from a representative from Linden Labs. Let me make sure I get the name right. I don't want to mispronounce at all. Done enough of that today. There we go. Ebbe Altberg. Dang, 0 for 3 today. Horrible. And so Eb Alberg from London Labs will be discussing the future of VR as user-created. I think that's a very, very interesting concept. Thinking about how, the most interesting thing to do in VR is to create the universe as you see fit, right? That's a really, really cool thing to explore, a really cool idea to explore. So we'll be looking forward to hearing from him in just about 4 minutes. So hang tight.